Our goal is to calculate the volume of a solid. So for example, if you have a loaf of bread, how do you calculate the volume? The idea is to divide this up into smaller pieces and then calculate the volume of each small piece, add them together, and then, as you remember, using the smallest width and sending that width to 0, and then defining the Riemann sum, calculating the volume using definite integral. For the melon here as well, how do you calculate the volume, right? Basically, we are slicing these into smaller pieces. So this idea is related to the Riemann sum and the definite integral. What is general slicing method? Suppose a solid object extends from A to B on x-axis, and the cross-section of the solid, which is perpendicular to the x-axis, has an area given by a function like A. This function is integrable on this closed interval A to B. Then the volume of the solid is the definite integral of this integrable function. And since we wrote down everything in terms of x, we take the integral with respect to x as x ranges between A to B. So for the loaf of bread, the cross-section is not very nicely recognizable here, but in general, our goal is to find this A and then plug that in here and start taking the integral. So this is the idea behind the volume. And last time we saw a pyramid, and the cross-section of the pyramid was x squared, and we saw how we take the integral. Let R be the region in the first quadrant. It's bounded by the coordinate axis and the curve y equals to 1 minus x squared. A solid has a base R and cross sections through the solid, which is perpendicular to the base, and it is parallel to y-axis, and they are squares. Find the volume of this solid. So these are the information that are given to us. By looking at the object, here it says you have y equals to x squared, right? So if you flip this, it makes it easier for you to see x-axis, you have y-axis, and the vertical line is z-axis. And please note that since we are on the first quadrant, everything is positive. So x is positive, so as you can see, we stop here, it doesn't go further. Y is positive as well, and z as well. So when you look at the cross section, which is perpendicular to the base. So this is your base, right? This is the base that you have. And then the cross section, which can be visualized this way. Perpendicular to the base, and it is moving, right? This guy is moving. And just visualized another piece here. So that's how we measure the volume, because this guy, this cross section starts moving. As x and y change, your cross section change as well. Okay, please pay attention here. Your point on x-axis has 0 y value. But if you take a point on this curve, this parabola. Your x value is x, but your y value is 1 minus x squared. This is based on the definition of this parabola. So these information help us to set up a of x, if you would like to use that one, and then do the calculation. So the general slicing method says the volume is the definite integral, but here x ranges between 0 to 1. It doesn't go further to the other side because we are in the first quadrant. So x starts from 0 and stops at 1 because 1 minus x squared. If you set it equal to 0, x squared is 1. So you have two choices for your x. X is 1 or x is negative 1. But negative 1 is not acceptable. Why? Because we are in the first quadrant. So that's why your x starts from 0 and stop at 1. This guy is equal to the definite integral of 1 minus x squared times 1 minus x squared. Here you have two sides. You're finding the area of this object. The area of this object is 1 minus x squared times 1 minus x squared. That's how you end up with this exponent 2 here. And then we take the integral with respect to x. Well, if you write this in expanded form, 1 minus x squared to the second power is 1 minus 2x squared plus x to the 4th. Again, remember that. If you have a minus b to the second power, this is a squared minus 2ab plus b squared. This is basic algebra. So 1 minus x squared to the second power is 1 squared minus 2 times a, which is 1, times b, which is x squared, plus x squared to the second power. That's how you end up with 1 minus 2x squared plus x to the 4th. Okay. How do we take this integral? The integral of 1 dx is x. The integral of 2x squared is 2/3 x cubed. And the integral of x to the 4th is 1/5 x to the 5. We are basically using the power rule. Your x ranges between 0 to 1, but plug in 0, the whole thing disappears because everything has x. So you just need to plug in 1. If you plug in 1, you get 1 minus 2/3 plus 1/5. And if you take the common denominator, 15, you get 15 minus 10 plus 3, which is 8 divided by 5.